Good morning, everybody. So, how many of you are developers? Okay, that's very good. How many of you are .NET developers? Okay, also a big amount. Okay, so today I'm going to show you how you can use Azure Data Lake to do big data analysis without having to know all the open source stuff. And to do that, I'll use the StackExchange dataset, which is all the information about all the StackExchange websites, which are more than 150, I think. So first, my name is Tom Kerkhove. I'm an Azure consultant at Codit, and I'm a Microsoft Azure MVP. I also write a white paper about IoT and integration if you're interested. But you can also follow me on Twitter or follow my blog. So today I'm going to introduce you to Data Lake, what it is, and how it compares to a data warehouse, and also what Azure DataLikeStore and analytics is. So first, big data was a big hype a few years ago. Now it's just a given, where we collect as much data as possible so that we can later on learn from that data, build machine learning models on top of that, etc. But big data also means that it's harder to process that data because the amount is a lot bigger. So it all started with Hadoop, and then all these other open source technologies started. But the problem is that I, as a .NET developer, do not know any of these things. And also, there's almost no .NET support. So if I, as a .NET developer, want to start with big data analysis, I could either use those, but these have a couple of problems. So one is being it's a new language that I need to learn, and possibly even more, because every technology also has a certain flavor for querying, etc. And I also need to maintain them. It's a rapidly evolving ecosystem, so it also means that I need to keep up with it. But the biggest problem for me is that it's also cluster-based technology. So in order to start playing around with it, I need to set up a whole Hadoop cluster and put all my data in there. So it's not very cheap to do that, and I cannot run this locally. Last but not least, for a lot of people, Linux is new, and that can also be a hurdle. Now that .NET is going cross-platform, this is a bit going away, but it was a blocker for me a few years ago. So this brings me to Azure and how you can do big data analysis. So there are three main areas in Azure. So on the left, you have DataLikeStore, which is obviously a data store, and is basically in a data lake format. I'll go deeper into that, but basically there's no limitation in the size of data that you want to store, in what format and whatsoever. Then you have Data Lake Analytics, which is basically a serverless query service that's built on top of Yarn, but I can simply write a script with the pointers to my data sets and where I want to have the results, do some querying and transformation, and I don't need to worry about what will be running my query itself. I just write the business logic, give it the script, they scale it out for me, and I get the result. So it's a pay-as-you-go model. And then on the right, you have the HD Insight service, where basically you can run all the open source stuff that I showed. They will host the cluster itself for you, and then you can use that technology. I will not go into detail into that one, because as I mentioned, I don't know any of those technologies, and it's beyond the scope of this presentation. So let's start with DataLikeStore. So DataLikeStore is a fully Web HDFS compatible data store, which means it fully integrates with the traditional Hadoop and other services, being I can use this for the data lake analytics side, but I can also use this for Hadoop or any other big data service technology, sorry. So this is basically the big data store in Azure. You can store data of any format and any size, being it's a CSV, XML, a zip file, they don't care. And it's a write once and read many principle. So once you upload a file, you either rewrite it completely, or you add a new file. So there's no way that you append to a file. Another big benefit, and sometimes this is really important, is that it has enterprise-grade security, meaning that it's fully integrated with Azure AD. So if you want to get access, your Azure AD user needs to get access, and this can be on a variety of levels inside the store, which I'll show later. But basically, this is the big data store in Azure. As you can see, it integrates with whatever you want. So obviously with the rest of the data lake services, but if you have an on-prem Hortonworks cluster or something, you can also use this. And it's basically the center of the whole process. So on the ingestion side, you can import all your data with a variety of tools inside the data lake itself. Then you can use specific services to process the data, other ones to visualize them, and you can also download them if you want. So today we'll use Data Lake Analytics and Power BI to have the kind of end-to-end experience. Along with, I used PowerShell, which is not on the graph on the left, but I used PowerShell to upload the raw data in DataLikeStore, and then I proceeded with Data Lake Analytics. But more on that later. But basically, you can use it with a variety of services in Azure. So the term data lake is a bit new. Before that, we were used to having data warehouses. So what is the difference? So a data lake is really a lake without any structure. So I can put my own data sets in there, which has a certain schema, while my colleague puts a different file up there, which has a totally different schema, and probably even a different persistence type. So it's completely raw, unstructured, semi-structured, or fully structured, and I can dump all my data in there. So this allows us to do exploratory analysis on the full data set. So I do not need to transform my data when I import it. I just give the full data set. While with the data warehouse, you define a schema up front, and every data that you want to import into the data warehouse needs to comply with that schema. This means that you potentially need to throw away certain data attributes, which is a downside if you want to do exploratory analysis, but this also provides you with a certain structure so that you know what's in there, which is a problem with the data lake, because if you do not have any metadata describing what data is located where and what it needs to be used for or whatever, your data will turn into a data swamp, which you do not want to have. So Martin Fowler actually wrote a nice article about this, and the full article is on that link. But basically, so a friend of mine compares this with if you want to eat fish, you can either go to the warehouse where it's already prepped, or you can go to the lake where you start fishing and basically get the full fish, which you need to clean, and yeah, you know how it goes. So it's just, it all depends on how you want the data to be prepared or not. So based on that, you need to either choose for a data warehouse or a data lake. If you want to do big data analysis, data lake is most of the times the best option, because then you have the full data set. So security, first of all, you can use role-based access control on the store instance itself, meaning that I can give access to people who can manage the store, who can change the permissions, etc. And then next to that, I can grant specific users and groups access to the whole data lake, to a specific folder, to a specific file, etc. So basically, you can see this a bit as a drive on your disk where you have a complete folder structure with files in it. That's how you can see a data lake a bit. And then you can also put the access control on a specific folder or file. It also comes with a firewall, which is unfortunately off by default, but meaning you can fully isolate the data lake and only give access to your applications, for example. And they also have encryption addressed, where you can either use the keys managed by Microsoft, or you bring your own key in Azure Key Vault, which I will show later. So pricing, just for your information, but it starts at 23 cents, 32 cents per gigabyte per month, and I think that's even the most expensive tier. So the more data you store, the cheaper it gets. So it's not a lot, but as you can see, you're also charged per write and read, which is fairly reasonable in my opinion, but okay. So Azure also has another service called Blob Storage, which was used in the past before DataLikeStore was there. So actually there's a few differences, but the difference is that DataLikeStore has no limitation in size and format, while Blob Storage also has a certain limitation in the total amount of data that you store. However, in the last couple of years, they've been increasing that amount so ridiculously that the trade-off over there is almost gone. But there's other differences. So Blob Storage does not support Active Directory authentication, which is a big request. It's not there yet, but in certain enterprise scenarios, this is really important. And then this is where DataLikeStore really makes a difference. But this also comes with a downside, of course, is that DataLikeStore is a bit more expensive. So if you provision a storage with geo-redundant storage, it's still cheaper than using DataLikeStore. However, DataLikeStore is fully designed for these analytical workloads where you read really a lot. And that's where it also shines more than Blob Storage. So if you want to run analytics workloads, that's where DataLikeStore is built for. They both have redundancy. The difference is that with Blob Storage, you can choose whatever kind of redundancy, so local, zone, geo, or geo with read access. However, with DataLikeStore, you do not have access to the replica, and also not how far it's being replicated. So if you need this can also be a downside. On the flip side, they both integrate with Data Factory, Data Catalog, HD Insight, and others. There's a nice article which gives you a full comparison if you want to learn more about this. So we will use this data set to basically show you how easy it is. As I mentioned, there's more than 280 websites. The idea is that we will basically upload the original data set, which you can download. I'll show you where. We'll then move that raw data, which is on the VM, upload that to Azure DataLikeStore. Then we will basically use Azure Data Lake Analytics to aggregate all the information across all the websites into one big file so that I can run queries on top of that. While we are doing that, we are also going to change from a XML dataset to a CSV, because scaling XML processing in a big data scenario is really bad because they tend to split your files into multiple smaller ones to fan them out. If you do that with XML, you lose your complete structure and you're basically screwed. So we're getting rid of the XML. Then once we have that aggregated file with all the user information in it, we will basically create a file where we have we will group them by country, and then we will have an average of upvotes, downvotes, reputation, etc. And then we will use Power BI to visualize that. Okay? So this is a very basic high-level overview, but I basically created a VM in Azure where I downloaded the raw information from archive.org. There's two reasons why I'm using a VM and not my local laptop. One being I don't want to leave my laptop on for a lot of hours because they provide you with a zip file which you need to unzip, and believe me, it takes a long time. But the second and the most important part is if I upload all that data to Data Lake, I need to pay. If I download it in the same data center and upload it then, it's free of charge. So I did that with PowerShell. Then it's in Data Lake. We will use Data Lake Analytics, and then we will create a report straight from DataLikeStore. Okay, so I'll show you a bit of DataLikeStore before we start with analytics part. So before we start, all the scripts and things are on my GitHub account. So if you want to learn more, it's all over here. So you can basically do it yourself if you want. And all the data comes from archive.org, which StackExchange actually publishes a data set, I think, every 3 to 4 months. So if you want to do it yourself, you can basically download them on the right. I use the torrent because otherwise I need to download 350 files, which is a lot. But it's all open source. You can simply use this. So feel free to get cracking. So let me zoom in a bit. So if you go to the portal, I hope the Wi-Fi is kind today. You can create a DataLikeStore account very easily. So the only thing I need to provide is give it a decent name. Zoom a bit. So I need to provide a name and link it to my subscription and research group. Then I choose the location where I want to move it. And then I have the option to either pay as I go or use a monthly commitment. If you use the monthly commitment, it's a lot cheaper, but of course you commit to store a certain amount of data. This can go up to 33% of price reduction. So if you have a lot of data, you might want to consider this. And then the other option I have is if I want to either encrypt my data or not. Come on. And then I can either choose to use a key by DataLikeStore itself. I can either choose not to encrypt or use one from Key Vault. So if you use Key Vault, then you basically need to select the vault you want to use. So NDC Minnesota. And then I can basically select the key I want to use, which is, I use one of the new RSA 4000 ones. Well, this is apparently not supported, but I can simply create a new one and link it, etc. I already provisioned that one because I want to show you that if you provision it, there's a last step of setting the account up where you basically need to grant this DataLikeStore account access to the Key Vault key itself, because Key Vault has permissions on the keys, obviously, and then you basically need to grant it. Normally, I think it's over here, but basically it comes down to you need to go to your account first, grant it access, and voila. So basically gives me a summary over here and gives me a button to grant permissions and enable it. However, for this demo, we are using a DataLikeStore account where the encryption is managed by Microsoft. So at a first glance, you see how much it costs for me and how much data there is. So I already ran the script to basically move the data inside my DataLikeStore account. I'll still show you how to do it, but it takes a long time, so I already did it. So you see how much data there is. You see the read and the writes, ingress, egress, so this can be really interesting if you have a big data lake. And then firewall, obviously, over here you can turn them on, and whitelist some IPs. And then the interesting part is over here. So if I want to browse my data lake, I basically get a simple folder structure. And in that folder structure, for example, you can have subfolders, and then you have files where I have this reference data which we will use. So this is a list of all the countries, their common names, etc. And you can see that I have a nice preview of the whole file over here. If I want, I can download it. I can change the preview so that, for example, the first row is a header. Now it should update the preview to use that. See, now it uses the header at the top, which makes more sense. Also, if I want to share this specific file with somebody else, but not the other ones, I can simply add a new user here, which can either have read, write, or execute permissions. So as you can see, it goes pretty far with this. I also can do it on a global level or not. So there's nothing fancy here. from a store perspective, but basically I see it as a big drive where I can have a folder structure where I can upload files. So I'll show you quickly the script that I use to upload everything. So this is an example of a file for a specific website. So on the left, you can see, and it's also in the GitHub repository, but I included a sample of coffee.stackexchange.com. And you see for every website, I have a XML for badges, comments, post history, post links, post tags, user, and votes. If you open one of those files, it looks like this. So what I did first was I created a PowerShell script to basically loop through all the folders on my folder and then upload every folder with its XML files into Data Lake. So that's the first step. So if I open up that script, it's actually very, very, very simple. Is it readable for you? Yes, okay. So if I collapse the functions first. So you see that I first need to authenticate with the Azure Resource Manager, where I select the subscription that I want to use. So that's just the regular Azure Resource Manager, PowerShell steps, and then I basically want to upload my local files to the DataLikeStore. So first I pass the DataLikeStore account name, where my local folder is, and where I want the folders to end up. So if you look in detail, and this is where the magic, to call it a big word, but basically we are checking if it's the root folder or not, and then if it, we basically remove the slashes because DataLikeStore does not like them. And then basically for every folder in my input folder, I process them. So I do some more cleanup, and then over here, I basically check, is it a directory or not? Actually, let me zoom a bit for this. So I check, is it a directory or not? If it is, then I check if the folder already exists. If it doesn't exist, I create a new folder via the new Azure RM DataLikeStore item, and I specify at the end that it's a folder. If it's not a folder, then I know it's a file, and then I basically say, okay, import this complete file to my DataLikeStore account to this location. And that's how easy it is. Just use 2 commandlets, so nothing fancy over here. So the next step is to change the format from XML to CSV, and basically use one script to fan out across all the files and aggregate into one consolidated CSV. So for that, we will use Azure Data Lake Analytics, which is I call it the serverless big data service. Why? Because I don't need to worry about any infrastructure. I simply give it a script with the pointers to my input files and output files, and I don't need to care about anything. And the beauty of it is I can use a syntax which is called uSQL, which is basically a mixture of C# and T-SQL. And that's perfect for me as a .NET developer because I know both of them. I can also use extensibility in C# or I can even use inline C# in the script itself, which I will show in a few minutes. But basically, if I submit the script, I can also say I want to use one analytics unit, is what that's a billing model, but I can basically decide how much compute I want to use to fan out the processing. So the more analytics units, the more chance that it will go faster, because it's not a guarantee that it will go faster. But I'll show that in details, because they also provide you with tips on how you can optimize your scripts. And I only pay for the processing time itself, not for the infrastructure. There's a couple of data stores which you can query or write to. So the main one is obviously DataLikeStore. The other one is Blob Storage. So I showed you the comparison. If you still want to use Blob Storage, it's still possible. And I can also query any SQL flavor. And I think you can even query SQL managed instance nowadays as well, but I'm not sure. And the beauty is that I query the data in the service itself, not in Data Lake Analytics. So basically it says, DataLikeStore, give me all the information, and once you have that, give it to me. So it's not being done in Data Lake Analytics itself. And you can use a variety of stores in one script as well. It's not that you need to use only one of them. You can combine them, and then you can output it to either storage or DataLikeStore. It also has built-in partition tables in Data Lake Analytics itself, but we're not going to use them. So how does the script look like? So it consists of 3 parts. So the extract, where you go to your data store and get the data set. Then you transform this with, however you need to do. So basically, this is your business logic. And then you basically output it to wherever you want. In this case, it's a CSV file where I can either, so we're outputting the @res, which is one of the transformation results. So basically, we capture that in a variable. Then we say output this variable, which represents this data set, to this file, and I want to output it as a CSV. There are other outputters available as well, or you can write your own outputter. Same goes with the input. You can use the built-in extractors, or you can write your own. That's what we're going to do in a few minutes. So it's not really that hard. It takes a few moments to start because it sometimes has some different concepts, but it's fairly easy to use. So the extensibility model is just here for your information, but you can use inline C# expressions. There's also code behind for every script, or you can use C# assemblies, which has these functions, operations and aggregators, and then you have more of them if you need them. There's a whole metadata model behind it, so you can see your Data Lake Analytics account, which has multiple databases, so a bit like SQL, where you can basically add C# assemblies that can be used by scripts, where you have tables, views if you need them. So those are the partitioned ones. You can also add procedures, table types, etc. What happens if you submit a script? It's actually very nice. So you submit a script to the service. They compile it for you. If there are compilation errors, it's already blocked. You do not need to pay anything. So imagine a typo in C#, for example, is already blocked there. So then they basically have this execution plan for you. Then they give it to an optimizer. That optimizer will obviously optimize the execution plan. Then the job scheduler and queue will basically take that script, give it to the job manager so that he can basically start the processing. And then that job manager will do the vertex scheduling. So basically, depending on your script, it will basically shred it across multiple vertices. So that's basically pieces of your data set, which allows you to scale out the whole processing. So if you have 100 vertices and you have one analytics unit, they will all be processed by the same. If you have 10 analytics units, it will basically scale them out across those 10 instances. And then the output is going to be written by the data store you are using, in this case, DataLikeStore. There's actually a nice presentation on how you can tune your scripts if you want to learn more. It's on that URL. And this is a result of how it's basically creating the whole execution tree. And the nice thing is, I don't need to know anything about it. I just write the use SQL script, which is fairly easy, and then it optimizes into one of those overviews. Job status, just going to skip it. The same security model applies here. And I also can give them access on either the whole instance or a specific database. So if you share one data lake analytics unit across the whole company, you can still create the separation with the databases. So this is also very nice. You can also apply limitations on an account level or a job level. They actually have nice documentation on this. So I'm not going into detail, but it basically comes down to avoiding that a developer submits a script with 100 analytics units instead of 10, for example, because that's the amount that you pay. And there's also a capability where you can apply priorities based on who is submitting them. so that if there's a production script that needs to run and there's a test script queued as well, the production job will have priority over the other one. Okay, so let's get started. So first, you can either use Visual Studio Code or Visual Studio itself. So I'm going to use Visual Studio. It's simply a plugin that you install, and then you can use this. You can run the queries locally as well, so this is a very big benefit. You can unit test all your custom code, also a big plus. For this demo, I'm just going to use the Azure offering because I want to show the portal as well. But yeah, that's basically it. I'll show you some stuff on the way. So this first script is very simple. I'm saying that I want to get all the information from all the user files in the XML. These are the attributes in my XML payload. So if you check ID, display name, and reputation, if I open the user's file, reputation, creation, display. So it's basically linking to these attributes. But then, so I'm basically describing the columns that I want, and then I say, get it from this sweb HDFS account, which is the StackExchange DataLikeStore account, which has a folder 2017 June. Then I have this placeholder, and then I have the file name. This is actually very powerful, because by using this placeholder, I can basically say every folder that is in the 2017 June folder, I want to have that in my column set. So I know that this entry belongs to this website, and the other one belongs to the other one. So this means that if I submit the script, it will basically go through all these folders, process all these user files, and load them with my custom extractor, which I'll show you in a minute. And because I want to use this custom extractor, I also need to reference at the top that I want to use that assembly. That assembly needs to be registered as well, with a uSQL script. I'll show that after this script. But basically, once all the input rows are loaded, I'm simply saying output this to the aggregated data 2017-06 users.csv, where I use the outputters.csv built-in outputter. And the difference here between the from and the to is that it doesn't prefix the DataLikeStore account, because you can also use a default DataLikeStore account. So if I don't use the prefix, it's going to use the default DataLikeStore account. So, and this is how I need to register my custom code. I'm just going to enter so it's on the whole screen. But basically, I'm saying deployed, I want to use database master. If there is already an assembly with this name, drop it, because I have a new one. And then create the assembly with the same name from, and then it basically links to DataLikeStore. So this means if I want to deploy my custom code, I first need to upload it, so I can use this uSQL script to deploy it. You can also do this from Visual Studio, then you don't need to upload it, but yeah, you should use a decent CI/CD pipeline, not from Visual Studio. But we've seen the script to deploy it, but what is it actually? So it's very simple. So I pull in a NuGet package, which is Data Lake Analytics Interfaces, and then I implement the I-extractor, which means that I'm creating a custom extractor. Then I just need to implement the extract method, where I'm basically going to load the whole file via simple.NET XML reader, and I'm going to parse it. So while I'm reading, and the node is an element, and it starts with the local name row, which basically maps to this entry here. I'm going to take the name of the attributes, sorry, the value of the attribute, and if it's there, I'm going to parse it. So if it's a string, I basically need to do some magic because there's a limitation of 128 kilobytes. So I clean it up a bit, and if it's not a string, then I need to basically cast it to the type that was specified in my script itself, and this basically comes back to these types. So if I see that it's an integer, I'm casting the field to an integer. And the beauty is that I get all this information as an input. So I can basically map this all together, and that's it. That's how I wrote my own XML extractor. There's one big caveat here, and this is that I need to mark it as atomic file processing true. And this means that if this file is being processed by, if a file is being processed by this extractor, it should not shred it into multiple pieces, because then I lose my XML format. If you are creating a custom extractor where there's no hierarchy in the file, you should simply remove this, because then it's more scalable. But because it's XML, I cannot do this. Okay, so we've seen how we can deploy a custom assembly, how we can simply load a lot of files with an extract script, and how we can output it. So before we can basically run this script, we need to have a data lake analytics unit. Data lake analytics instance, sorry. So to do that, we go to the Azure portal. We do add, and then we wait. And the setup itself is also very simple. I give it a name, I give it a subscription, and I link a default DataLikeStore account. Why? Because Data Lake Analytics needs to store metadata as well. So what databases are there, what store procedures, etc. So I can select one of those. Then I click create, it's going to be provisioned, etc. And then I can run queries against this. However, I already provisioned this. We are not only using our default DataLikeStore account, but we are also using the the StackExchange DataLikeStore account, which I already have. So that's where the data set is available with the original XMLs. So to do that, I need to go to data sources and basically add a link to that other DataLikeStore account. So you can see over here, the default is the NDC Minnesota Data Lake one, and the other one is the StackExchange one, which I can reference in my scripts. So if I'm ready, at the top you can see here that I can submit one where I specify the DataLikeStore account, the database and the schema, but also the AU, so that's the analytics units that I mentioned. So if I provision 5 analytics units, it will be more scalable in terms that it will separate the files across these instances, but it will not separate the files across into multiple pieces because of my extractor. So I can simply click submit. Yeah, let's just do it. Not going to wait for the output anyway, but at the bottom you can see that it's preparing the script, validating it, and it actually submitted it, etc. But the beauty is, if I go to the portal and back to the overview, it's not submitted yet. Come on. Actually, while it's loading, let me quickly show the StackExchange storage first so you can see the structure. So over here. There's 570 gigabytes because I have 3 dumps in there. So we are using this one from last year. Then you see one folder for every site. If we go into one folder, you can see all these files. Again, if I want, I can click on preview, but because it's XML, I think it will be a bit messy. Yeah, see. Anyway, you get the idea. So now you see that the script has started. On the left, you can see the status. and some more information. And at the top, you can see that it's now processing 328 files. It's doing the extract, and then it will do the aggregate into one file. So if I'm feeling lucky, apparently they removed the support, but normally you were able to basically show all the blocks next to each other. But with the last update, I think they removed it. Yeah. Anyway, if I go to the portal, I can see the same experience. Come on. So now you see that there's one script running by one submitter, that's me. If you have multiple people, this will be a nice location where you can see who is using what, and you can also see how many analytics units are now being used. So you see that there's a limitation of 250 for my account. Then you can see, we're running out of AU units. We should separate or request more via support. And then over here, you can also see the job statuses. So 3 of them succeeded, 1 is active. And here you can see how much hours of AU we spent, because that's where you're paying for. And here you also see how much I've spent in the last couple of months. If I go over here to view all jobs, you will basically see that my current job is running. And you will have the same experience as in Visual Studio. So building the graph. Come on. It also shows me how much, where did it go? How much files it's processing. Okay, so I already did this. So we do not need to wait for the output. And then if I go to Visual Studio, you can also see your, come on, it's this one. You can also see your data lake analytics units over here. So now I can also right-click on jobs and get the same list of jobs that I saw in the portal, but in Visual Studio, I can go to the details, etc. Another thing you can do is go to the storage accounts. So for this analytics unit, I link 2 storage accounts. So you can see them over here as well. Also, which one is the default. But the nice thing is I can also browse the data lake inside Visual Studio. So now that, for example, I know that my job has finished, I can go to my folder, aggregated data 2017-06, and then you will see all the aggregated CSVs. So it also shows you how big they are. It's not that big because it's an aggregate, yeah, not super big, but okay. It's good for demo. And then if I want, I can basically double click. Yes, it's a preview. Please don't download the whole file. Come on. Okay, and now here I can see a preview of the file that's stored over there. And then you can also see the names of the websites in the first column. And now imagine I'm a data guy who wants to know what's in there. He can browse it over here. We already know what's in there. So what we will now do is, and I should have turned on to output the, so what you can do basically, let me actually show you this, if IntelliSense is friendly. Yeah, I don't know the name. I think it's preserve headers. Yeah, don't know it by heart, but basically I can say if you output the data set, include the name of the columns so that it includes as a header row, so that I now know what these, where is my preview? I know that column 0 is the source from the data set, but if somebody else looks at this data set, they do not know this. So I should have turned on the header row. But anyway, so we will look at column 2, which is the name. So you see that one person can be added in multiple website files. And there's also a column 6, which includes the location. So we will basically use those two fields along with the averages of vote up, down, etc. And then basically visualize this. So there's a small limitation. My script does not check for states or cities or whatever. It simply checks, does it contain one of the supported country fields, because you will see that there, it's not in, it's at the top, see? There's a test account which is always on the server farm. My script will not detect them. So what did I do? 50 minutes left, so I need to hurry. But basically, I'm now using the built-in CSV extractor to load my previous result. I also specify what I want, capture that in a variable. Then as a second step, I also load my metadata file, so my reference data, which has all the countries and the friendly names. And then I know which region of the world and sub-region they are in. And then I basically do a small cleaning of the data set for the users, because the location sometimes has spaces and other things. So for that, I'm calling a method which calls cleanse string. And if you check the namespace, it's actually the code behind of my script. So if I go to the code behind, you simply see that there's a cleanse string over here, which takes in a string. If it's empty, I don't need to do anything. Otherwise, I need to trim it and lower everything, because that makes the comparisons a lot easier. So this means that I don't need to deploy this custom assembly, because it's part of the script. The compiler will be smart enough to basically take it from the code behind and add it into the script itself. If we have some time, I can show you at the end. So once the users are cleaned, we do the same for the store, for the countries. As part of the scripts, I actually do two things. I check how many people specify their location. Of that, how many were we able to locate them to a country, and also how many of them did not specify a location. So here we're basically joining the reference data with the user data, grouping by region, sub-region, and name, and also doing an average and account so that we know the amount of users with the region and the sub-region and the average of the values. So then I have other ones where, hold on a second. Then I group. Yeah, so I'm then creating a set of of all the users, then the amount of users where we could not find the location, where it was not specified, and where we were able to link them. But we will not use this result. But basically here you can see that we're outputting the result of those two transformations into another file where I output the header as well, because this makes it very easy for Power BI to load that file and then see the result. So at the top, you can see that I submitted this query this morning with 75 AUs, which is actually very expensive. And then you can see over here that it all results into this execution plan. But I don't need to care about how this is being modeled. They are doing this for me. I just write my script of what I want to do, and I submit it. So the nice thing is, if I load the profile of that job, it gives me some warnings. That's because I over-provisioned. And then I can basically rerun that script to see, and at the top you can select by progress or computation time or whatever. But by replaying it, I can see where the bottlenecks are in my script. So if it took too long, I can see, okay, this extract took too long. I should maybe optimize it in the previous step or whatever. So this is really nice. Next to that, it also gives you the overview of your job. And here you can see that I provisioned 75 AU units, but in reality, it didn't even use 20 of them. So my efficiency at the bottom here is 5%. And they suggest to me that if I want to have a balanced processing, I can use 8 AUs which will be 69% efficient, and it will only take 44 seconds. And the estimated time is 0.1 hours. If I want to be very fast, I can still provision 11, which will be, funny enough, same time. And then you can also use this custom one, where I can basically use the slider and see if I provision more, what's going to happen. Okay, not efficient. If we do this, so basically this allows you to, this was a one-off script, but you can have recurring jobs. So this allows me to optimize for the next sprint, for the next job, so that I need to pay less. This is all built in, so this is very nice. Fair warning, this is based on machine learning, so they analyzed a lot of jobs in the past. This is only a prediction. This is not a guarantee that this will be the outcome of your job. So don't just take this as what's going on. So quickly, where is this again? Here it is. So basically, you can see the submitted script after it was optimized. So we see at the top, it's creating an assembly and referencing it. This is referencing the code behind that I was adding. Then you see that it's using the same script that I added, and I think at the bottom, I don't know, it's dropping the script again. I thought that they were going to include it, the code itself, but they basically did it over here. So that's why I don't need to deploy it myself. So back to the portal. Actually, over here, it has the same capabilities. I ran it this morning. Come on. Where it has the same AU analysis. So this means that if I submit it, somebody else from the team can see, Tom provisioned too many AU units. Then he can basically determine what the best approach is, and then he can decide what would be better. And also you can see actually that the suggestion here is different than what I had in Visual Studio. Because now it says the most balanced and fast is the same, where you should allocate 6 AUs. And it will take 0.16 hours instead of the balanced only taking 0.1 and the fast 0.2. So you see this is more up to date. So I'm running out of time, so I need to hurry. But now that we have the result, they also, it's already gone, but every job also has a URL. So if you want to share or collaborate on one job, you can basically pass that URL around, which is very nice. So in Power BI, I have this template. We'll probably not have time to do it all, but if you're interested, feel free to come and ask me. Basically, in Power BI, you have the capability to add a link to DataLikeStore. And then for the URL, I can basically link it to the file I want to use. Come on. And the reports. And then I think it's this one. And over here I can say properties, and then it gives me a URI to the file, and I don't know what's up with the portal. Stop jumping around. Over here. Click OK, and then I probably will need to authenticate because of the security. So no typos. Okay, so I click connect. So now it's pulling in the file. You will notice that it looks a bit odd. So you'll see this. Why? Because it's pulling in actually the metadata. So what we're going to do is we're going to change this data set, where we say instead of all this metadata, I actually want the binary content. Then it's going to pull that in. Basically, we're now changing our data set on the fly. So you can see this is the result of the script, where on the left I have the location, I have the region in the world, then I have the sub-region in the world, and then all the other information. And because I turned on the option to output the header row, Power BI automatically detects these labels. So the first time I did that, I did not have that, and it was actually a bit of a pain because I had to check my script. Okay, column 3 was this field, so I had to basically change this data set. I click close and apply. And now, once it's finished, I can basically create my reports. Come on. And then I can basically just say, okay, values. So for this location, show me the reputation, and then you see San Marino has a good reputation, etc. So to save us some time, I did this up front, but basically you can create these nice overviews with the result, where you can just drag and drop all the data that you want. And the nice thing with Power BI is if I click, for example, on Europe, if I click on Europe, you will see that every graph is going to change without having to do anything. You'll also see that I have an anomaly because something in Asia is linked to my Europe data set. So it's not that fancy demo, but I wanted to give you an end-to-end example of how you can go from a raw data set to a nice report by using 2 scripts, 3 scripts if you include PowerShell. So quickly going through the rest of the demos in 3 minutes, but I showed you the Storage Explorer and the Job Visualizer in Visual Studio. In Visual Studio Code, you can do the same. It has source control integration. The SDK is also available as a CLI, so you can use any build agent and just use MS Build. You can unit test everything. Pricing is very interesting. So it's about 2 cents per minute, which is fairly reasonable if you ask me. So the longer it takes and the more units you provision, the more expensive it will be. But again, you have the monthly commitment packages which can save you up to 74%. So that's really a lot. Operations is also important. So here's a nice overview of what's all available. I don't have any time to show it anymore, but something they added recently is to create alerts with log analytics, so that if you spend, if you have a job that exceeds 1 hour, let's say 50 hours, then it triggers an alert and operations can have a look because probably it's hanging or anything. Then another very nice integration is Data Factory, which allows you to create these data pipelines, and part of that data pipeline, you can basically say, run this script. I'm actually working on a blog post on this where I basically use Data Factory, Data Lake Analytics, and Logic Apps to automatically aggregate all the user information in a fictitious application, so that if that user wants to have all its data and download it, which is one of the requirements for GDPR, it's basically combining these 3 services into an automated process to go and fetch it in DataLikeStore, run a query on top of it, go to a SQL database, get all the information, and then basically move it with Data Factory as well. So if you're interested, you can check my blog for that. And if you want to learn more, there are some nice resources. This is a really good book. If you want to read more, it's more in general on data in Azure itself. as well as the data architecture guide, which basically describes a lot of scenarios and the options you have in Azure for this. And then a small summary. Big data is not just a hype anymore, so if you're interested, you should really get started. DataLikeStore is nice to analyze what you have tomorrow or what you want to learn, what you have today or what you want to learn tomorrow, because you're not throwing away any data. But be aware that you're not creating data swamps if you do not have any structure, so this is really important. If you decide to move your data around in the data lake itself, you can either use Data Factory to create a copy or Data Lake Analytics. It's up to you. Data Lake Analytics is really nice in my opinion because it's serverless. I can reuse my existing skills and only pay for what I want to do. And then the last point is if you want to do big data analysis in Azure, Data Lake is the place to be. Thank you. Any questions? No questions? Yes? Then the script basically comes into a failed state. And then not, sorry? It's the job will be failed itself, then you need to check, okay, the job says it failed because of this, then you need to fix it and then resubmit it again. So you will pay for the amount of time it already ran, and then you will need to spin up a new submission of the script itself and hopefully fix it. Is that an answer to your question? Okay, any other questions? Okay, thank you.